Greetings. Today we'll be reviewing the basics of how to operate the function generator and the oscilloscope, including just how to set them up and some features of triggering. So first of all, let's start with the oscilloscope, which you see here, of course. This oscilloscope has two inputs, channel 1 and channel 2. The signals come in on the center of the coax connector, the center conductor. The ground, the outer part of the coax connector in most oscilloscopes is connected to the chassis of the instrument, and you should assume that unless you know otherwise. This two-channel scope allows you to display two traces, of course. In this case, channel 1 shows up as yellow. You can see that down here, whereas 1 shows the yellow and 2 shows up as this magenta color. And obviously you need to set up each channel to see the trace that you're interested in. Now, before we say more about the oscilloscope, we want to feed some signals in. This over here is a function generator, and as a function generator, it is pretty easy to send out sine waves, square waves, triangle waves, and ramps here, as well as other things. And you can set the amplitude and frequencies of those and the DC offsets associated with them. The function generator has two outputs. Again, the outer part of the coax in each case is usually connected. In fact, this way it kind of shows you that it's connected to the chassis ground, this symbol right here. And the signal comes out on the center part of the coax. So let's take one of those. We'll take the one that's labeled output and put that into channel 1 of the scope, say. Okay. So we hook that up, send it over, and it's a little bit awkward here. All right, good. Okay. So immediately our 3.3 volt peak-to-peak signal showed up here. We can check that that's 3 volts peak-to-peak just by the fact that we have 2 volts per division, it says right here. And look at that. Oh, look at it. It doesn't look like 3 volts. It actually looks like 2, 4, 6 volts peak-to-peak. This is a feature of this function generator, and it has something to do with what's called the output impedance. So right now I'm not going to go through that, but this is a warning to you to not always believe this number right here. You should check it on the oscilloscope. Okay, so there's a factor missing here, but we're not going to worry about that right now. Okay, instead what we have is we have a sine wave coming out at some frequency. If I want to know the frequency, I can just press the frequency button here, and it says 1 kilohertz. Okay, and I can go over here and verify that it's about 1 kilohertz because I look for the time base, and if well, you can actually see that the frequency is it's already figured out that there's a 1 kilohertz thing going in, right? But the time base is listed up here. It's 2 milliseconds per division. So if you look at that, 2 milliseconds per division, it looks like the wave oscillates about twice in one division of the going across the time base. And so that's about a millisecond period. So yeah, that's about a kilohertz. So at least things seem pretty nice there. You should always verify that kind of thing when you're working with these instruments, especially digital oscilloscopes, because sometimes there's weird stuff that goes on with alias and things. So, okay, we've got a signal that we're sending in. We've got a frequency. We can change the frequency around by dialing this around. You see that the frequency gets faster and faster on the scope as I do that. I could change around the amplitude instead if I can ever figure out where the amplitude actually is here. Here we go. So I could change the amplitude to a smaller number, right? Here we go, 2.3 volts, well, except for it's double that. I can change it to a square wave. I can change it to a triangle wave. Now, the other thing we need to know about this is what is the DC level, okay? There is an offset that I can plug in, which right now is 0 volts, but I can dial that up, and you can see the yellow curve move up as I do so. All right? So we're going to take that back down to 0. And then think about the other output. Okay, the other output is called sync, or synchronize, and that is an output which is always the same waveform, always the same amplitude, but it's at the same frequency as the other one, and is at some phase relative to it. Okay, but at fixed phase. So sync, as you see here in the purple, is a square wave. It's going 5 volts, 0 to 5 volts, you see, roughly speaking, right? And as I change the amplitude of the yellow output, notice when I do that, the yellow gets bigger and smaller, but the purple does not. This is useful sometimes when we get into using other instruments like lock-ins and things like that. If I want to have a waveform going into my electronics that's very small, but I still need to know, need something that tells me the frequency somewhere in my circuits, this sync output is useful. But we won't talk more about that yet. Okay. Now looking at these, let's say that I just turn off channel 2. So here's how I would turn off channel 2. I select it, and then I select it again, and it's off. Okay, but I can turn it back on again by hitting that button. Okay, so I turn off channel 2 so it's not complicating things. I'm going to look at channel 1 instead. And one thing you'll notice here, if you look closely, let's see, I can change the time base, by the way, so that I can see, zoom in on the waveform. Okay, make it a different number of milliseconds per division. Here it's half a millisecond or 500 microseconds per division. So again, it's about 2 divisions, one millisecond period. That's a kilohertz. Okay, so one thing I should notice here is where is 0 volts for this for this waveform, for this sine wave? Well, that's indicated over here on the left-hand side. Channel 1, 0 volts is marked with a little marker there. Okay, it's a little bit hard to see. Let's see if I can turn the scope so it's in a little black spot for you. Anyway, you'll have to look at the real thing and see that it's right there. Off on the right-hand side is a triggering marker. Okay, so I'm triggering on channel 1. In other words, the scope is deciding when it's going to start displaying the waveform on the left-hand side of the screen. When is it going to start running that across? And I'm doing it such that every one overlaps every new waveform, so it looks nice. Okay, so we'll get that in a second. But another point is that I can change where this appears on the screen by adding an offset into the scope. And you can see that I can move channel 1 up and down. But I really should be aware of where the ground, or 0 volts, is for channel 1. And when I go over here to the amplitude button, or I'm sorry, to the offset button, you can see that now, as I dial this one around, it adds in an offset on the function generator side. So I'm not really going plus and minus volts anymore. I'm going from kind of 0 to some bigger volts. Okay. By the way, when this happens, what that means is that my triggering has gone bad. In other words, the scope is randomly sort of letting the output from the function generator drive the picture across the screen, and then the next time it comes back, it's doing it at a different phase, so you get all this mess right here. So this is a symptom of bad triggering, okay? And we'll get to that in a minute. Okay, so now that we know about that, actually let's get to triggering right now. The triggering is nice as long as it's triggering on a channel that has a good signal, and the trigger is actually somewhere in the range of that channel's signal. So now, watch this, as I move up, add an offset to the signal coming in relative to ground. You can see that the trigger's right here, okay? And pretty soon I go outside the trigger, and now channel 1 is never crossing the level of the trigger there. The trigger is, the scope is sitting there asking, is this waveform going through that voltage right here? And is it going through in the right direction? So let's actually go look at that setup. It's saying, okay, I'm going to look for an edge in the waveform, or a passing through of this voltage on channel 1 with a positive going slope. Okay? And when I see that, then I'm going to let the waveform drive scroll across the screen. Okay? So let's bring it back down into a nice trigger now. Okay? And what you see is we have overlapping waveforms every time that it goes across the screen. So that's a nice trigger right there. I had to tell it to look for a waveform on channel 1, right? I could use channel 2 as well, though, because channel 2, actually, if you remember, channel 2 looks nice right there. And I could tell it to go and use channel 2 instead, okay? And now we see that there's a purple trigger marker over here. So we can take that and we can move that marker up and down. In other words, what voltage am I looking for? And if I move it outside the range of channel 2, then things are going to go bad again. But if I put it inside the range of channel 2, it's going to look good. Okay? So, with all that said, let's see, what are we going to do next? The next thing that we're going to do is think about the modes of triggering. Okay, there's two modes that one usually uses. One is auto and one is normal. The auto one is the one that can get confused as you go like this, because what happens is if it doesn't see a regular trigger, then it just chooses after a certain delay to let the waveform go across the screen anyway. In normal mode, you don't get that. And the reason is, here, let's actually go like this. We're triggering now, right? If we go outside, it no longer triggers. In normal mode, it never decides to trigger unless it actually sees one. So that's important if you're looking for occasional pulses or things like that. That can be really handy. But in normal trigger, you're going to get a good thing. So now, one thing I have to say is that if you think you're looking at a good waveform, it should usually be having that little hash, the repeating hash on there. It shouldn't be frozen on the screen like this, okay? If it's frozen on the screen, that means that you're no longer triggering, right? The other thing is that if you think you're looking at a good waveform and you go to normal trigger and it freezes on the screen or something looks screwy, then things probably aren't good either. So auto triggering is really good for finding your waveform. Normal triggering is good for once you have it, okay, and sort of making sure that you're not screwing up. So let's look at how, in general, one might mess up with the scope if you're coming to it with a waveform and you're trying to find the waveform in the first place, okay? So the two things we need to know about are how to dial around for a given channel. Say I'm going to channel 1, how to dial around the voltage range that it's looking for or displaying, and how to dial around the time base that it's looking for or displaying. Now you'll notice that I'm not triggering, so it's doing funny stuff. There we go. Okay, so let's say I went over here and I changed the frequency. I'm going to change it to something really high, okay? So this is taking a while because I'm slow. But let's say I just am, I change it to that, okay? Now, what you can see is things look kind of funny over there on the scope, okay? Now, I know what I'm looking for, but imagine I didn't know what I was looking for. How should I approach trying to get a good signal on the scope? A lot of people would just say, hey, hit auto setup. Sometimes that works. If you only have one dominant signal coming into your scope, then that works. If your signal is mostly noise or something like that, then it might not work, okay? So instead, you should know how to set your scope up without hitting auto setup, because that's both a skill and it's a little bit more robust, okay? Generally, I know what frequency of thing I'm looking for. So I should first set the time base for the thing that I'm looking for. Let's say I know that I know it's going to be tens of kilohertz just because that's what I'm driving my circuit with or something like that. So if it's tens of kilohertz, well, that's periods of something smaller than 0.1 milliseconds. So I want to make that down to some small, something like that. That would be 10 kilohertz would be one division right there, okay? So maybe I want to go a little bit smaller. Now, my traces look kind of ugly right now, right? They just look like hash. But that's because I'm not triggering well. So let's say I want to trigger on channel 1. So I'm going to go to Setup, say, hey, take me to channel 1 to trigger. But imagine that it's off here like this first. Now the next thing I want to do is I want to actually try and get the waveform here to at least fill some portion of the screen. So I would go to channel 1 and I would change it around so it's kind of big like this, okay? The next thing I would do is go to my trigger, okay, and actually try to set the level such that that's good, okay, somewhere in the middle there. And then I would go to normal and I would ask, am I triggering? Am I triggering? And you know what? I can see that I'm actually triggering on normal triggering, but the waveform still looks weird. Well, I know that it's triggering well, so therefore my interesting waveform must be a much faster, faster frequency than is being shown here, okay? So I'm going to actually just speed up the time base, and look at that, right? Sure enough, if I speed up the time base, I'm actually seeing it. So rather than hitting auto setup, often what you'll want to do is just go to auto trigger first, get it triggering on the right channel, use your vertical control information, so how many volts corresponds to how many divisions here, to get a reasonable looking waveform up and down, playing with the time base to get it somewhere where you think it's probably about right. Don't ignore this number up here, okay? Often people will end up having bad waveforms because they've got it on something like 5 nanoseconds, and they're looking at it like this, and they're going, oh, but look, see, I've got this thing here. How come there's no sine wave here, right? Well, you know what? You're looking at ridiculously fast, a small part of the sine wave. If you just slow that down, then you'd actually get back to your home play with this, and then the triggering, and once you can go to normal triggering, life will be good, and you know you've got the right signal. So that's the basics of how to use the oscilloscope and how to use the function generator. We'll come back to this in another time and talk about the output impedance of this and the input impedance of this and AC coupling and all those kinds of things. But that's enough for now. So good luck.